Another one of our regular mates is back for 2024, and he is John O'Connor, Professor of Science from the University of Newcastle. John, a sort of Happy New Year, Christmas, Australia Day, tick all those boxes. You just get one welcome, all right?
Okay. Well, it's cheaper that way, isn't it?
It is, see? It's cost effective. Everyone's time poor as well.
And to you, Mark.
Yes, thank you. Back for another year of scientific discovery and some of the big things, some of the small things, and some that are, I think they're just downright curious. I think this one kind of fell into that category for me today.
Yes, and this one is breaking. It's sort of breaking news, and of course there's going to be more work done on it. But this is out of a couple of groups, the MIT and the University of Texas in the US, and they were looking at how to improve the evaporation of water. Now, it's an important issue because about 20% of the energy used in industries across the world go into evaporating water, and so the normal way you evaporate water is that you heat it up and you provide energy to all of the water molecules. Those near the surface that have just a bit more energy than all the others, the rich ones, they can go bing and jump out and off they go. And then, of course, the rest of the molecules, again, jump out. Eventually, others will get more energy than the necessary amount and they go out. So you're heating up all the water and a small amount get out from the surface. And they were studying this process and they were looking also to use light. Now, the problem with light and water is water doesn't really absorb light very well. It goes straight through. So that's not a very good way of trying to evaporate because ultimately you've got to put something black in there and heat up something black and then heat up the water. And again, that's a very inefficient process. But they started a few variations and between the two groups, they were finding one was finding something, and the next one was building on that. And they tried a material called hydrogel. Now, hydrogel is just a substance that absorbs a lot of water, usually at least 10%. So, think of a sponge. Right? It's not really a sponge, but that's the sort of thing.
Similar. Yeah.
And they found that with hydrogels, the thinking was that maybe the water wasn't as strongly bound, and so therefore it was easy to pull off. But that didn't explain the process. They found that it was coming off twice as fast as they expected. And after a number of experiments, they found out that some of the water was coming off directly from the interaction with a photon. So a bit of light coming in. Now that's a really efficient process because if you can send in one photon and you zip out one molecule or maybe 10 photons or whatever, that's a lot less than heating up all the water because water really takes a lot of energy to heat up. And just look at you standing there waiting for the kettle to boil. And so if you do it this way, you've actually got an enormous energy saving. And so what they're looking at now is what is it? What is the process? What is the wavelength? What wavelength do you need to get this more efficient removal of water from this surface, and therefore, evaporate water or desalinate water or dry objects. If you've got something that's wet and you have to dry it out, what is the optimum way of doing this?
And particularly, John, you mentioned, we sort of jump full circle here, is that, like you said, 20% of industry is devoted to that evaporating process anyway. So you can sort of get on top of that and make that more efficient and more cost effective. That's a lot of folks all of a sudden starting to pay attention to these processes.
That's right. And these days, given that we have so much control over light-emitting diodes, LEDs, where they can actually tailor the wavelength to the wavelength you want. If you can identify which wavelength does it well, you can then get the LEDs that do that. And LEDs are very efficient in terms of converting electricity to light. So that way you can actually, speed up this process, shorten the time for the process, and reduce the energy process all in. It's a triple bonus.
Excellent. All right, well, that's something we'll watch with great interest. And mate, first one done for 2024. So we'll look forward to seeing what you have for us, John, in a fortnight from here. Appreciate it.
Thanks, Mark.
Our Professor of Science from the University of Newcastle, John O'Connor, with us on 2NURFM 103.7. Good morning.
A broadcast service of the University of Newcastle.